Let's look at a common mistake in 8th grade physics: force analysis of a block on an incline. The difficulty for many kids is determining if friction exists, and if so, which way it points. In today's video, Teacher Yiwen will teach you a great trick, the brush method, to help you easily master this type of problem. After watching, use this 8th grade physics force analysis practice set. It covers 32 essential models prone to errors during winter break. Complete it, and you'll easily get full marks on force analysis when school starts. Parents who don't have it yet, I'll send you a copy. Let's take a look. Here's a stationary block. Let's analyze the forces acting on it. Observing the image, we see the block is on an incline, with its lower end subjected to a pushing force up the slope, right? Now, when many kids draw following my sequence of gravity, then normal force, then friction, let's see, they'll find that a problem with friction arises as they draw. First, let's draw the force of gravity, then the normal force from the incline on the block, which is perpendicular to the surface. In this direction, the support force, okay? And then there's a push force up the slope. This is a known force, so we'll draw it here. After drawing these three forces, think about it. This situation fits the three-way junction force model we discussed, right? These three forces could potentially balance each other out on their own. If not, friction pointing up the slope could balance it, or pointing down the slope might also work. So many kids can't figure it out. Is there friction acting on it or not? Therefore, we need to discuss the different cases. In fact, there are several possibilities here. First, for the first case, let's make an assumption. Assume that when the block is first placed, it isn't being pushed. Let's remove the push and imagine a block resting freely and stationary on the incline. When it's placed there, let's imagine soft bristles are attached to its bottom surface. Now, the bristles were originally standing straight, but on the incline, the block tends to slide down. With this tendency to move down the slope, it will naturally experience friction pointing up the slope. So as it tries to slide down, imagine how its bristles would bend. If it wants to slide down, the bristles should bend upwards roughly like this, right? This shows that the friction it experiences is actually directed up the slope. The point of this brush method trick is to help you easily determine the direction of friction by looking at which way the bristles bend. Okay, that's the case of it resting freely. Now, let's bring that pushing force back. When we bring it back, let's say we start by applying a relatively small push when F is small. Is it possible that even with this push, since it's small, the bristles that were bending upwards, it doesn't do much, it's still bending upwards, just a bit less so. But the overall direction is still bending upwards. Is that possible? Yes, it is. Well, if that's possible, it means the bottom surface is still experiencing friction upwards along the slope, right? Okay, so let's draw a free body diagram for this situation. Here's the block. It's subject to downward gravity, a normal force perpendicular to the slope, and the known pushing force upwards along the slope. Based on our analysis, the friction at this point should be upwards along the slope. So let's count the forces. In total, it should be subject to 4 forces, right? Okay, following this logic, let's continue to increase the pushing force. If we keep increasing it, can I push the bristles until they stop bending and become perfectly straight, returning to their original upright state? Yes, I can. If I just increase the force a little bit, it should work. In that case, since the bristles are straight, does it mean the bottom surface is still experiencing friction? As we said, the direction of friction can be determined by the direction the bristles bend, right? Now that they aren't bending, it means there's no friction. If there's no friction, what forces are acting on it? Is it just gravity? And the normal force, which is an elastic force. There's also the pushing force, which is also an elastic force. There's no friction, right? So it's balanced by only 3 forces. Okay, for the third case, following our analysis, I'll keep increasing the pushing force until it's quite large. At this point, won't the bristles bend downwards instead? Imagine I'm pushing really hard. Even if it doesn't move, the bristles will bend downwards, right? Now, it has a tendency to move upwards. It's almost on the verge of moving. So in this situation, the bristles will bend downwards. If they bend downwards, it means the friction is directed downwards, right? Now, the bottom surface feels friction downwards along the slope. It's resisting that upward tendency. So our force analysis shows gravity, the normal force, and the pushing force. This time, friction is acting downwards along the slope, right? Counting them up, there are still 4 forces. So this problem actually has 3 cases. The difficulty is in how a student can visualize all 3 scenarios and correctly determine if friction exists and which way it points. Based on our analysis, the answer should be that the object is subject to 3 or 4 forces. Did you get that?